Hi and welcome. My name's Michael, and in this lesson we're going to examine network masks. So now that we understand IPv4 addressing, and we understand binary, and we understand how we can represent IPs in binary, we can look at how network masking takes place. So let's get started. So I'm here in the network masks section of our interactive diagram. And this is where addressing in binary and binary IPs starts to kind of come together. So the network mask designates which section of the IP address applies to the network and which section applies to the host. So here we have 192.168.1.101, and if we look at an example network mask, we have a 255.255.255.0, in which case the 255.255.255 is going to represent the network portion, and the 0 is going to represent the host's portion. So looking back at the original address, if this is a 255.255.255.0, then 192.168.1 is the network and 101 is the host. And if we know that, then we know the size of the network and we can calculate the actual range. And so in this case, the range will be 192.168.1.0 to 192.168.1.255. Now, a couple things about the first and last address in a range. In a classful network, the .0 is not a valid IP as it represents the network. And in most networks, the last IP in the range or the highest IP in the range is considered the broadcast IP and isn't used for host assignment. Now, what is the broadcast IP? The broadcast IP is for broadcasting a packet to the entire IPv4 subnet, which, if you remember back here when we were looking at network traffic, broadcast is sending data to everything on the LAN. Now, there is some semantics around using the .0 in a non-classful network. By and large, an IP that is a .0 is valid. However, if it is the first IP in the entire range, in which case there is only one .0 in this range, 0 to 2.255, then it is generally not best practice to use that for host assignment. So now that we kind of know what the mask is, let's look at masking in general. So here we have 192.168.1.101, and here we have the binary representation of that. This should be familiar by now. And up here we have some common net masks. So let's look at that first one again, the 255.255.255.0. So what that looks like is all ones, right, for the first 3 octets. That's 255. And then zeros for the last octet. That represents the host's portion. The all ones masked off represents the network portion. And what we end up with is a range of 192.168.1.1 to 192.168.1.254. So we are not including the .0 for host assignment, and we're not including the .255 for host assignment. So it's basically the total number of IPs minus 2 to represent the first and the last. Looking at the next common net mask, we have 255.255.0.0. So here's our 255.255 represented in binary. So that is the network portion. The 192.168 is the network portion now. We're not including the .1 in the network portion. This is instead being included in the host portion. This is the .0.0. And what we end up with is a range 192.168.0.1 to 192.168.255.254. So it's more than 65,000 IPs and hosts. And then the last example here we have is 255.0.0.0. So now our host portion, or our network portion, is even smaller, and our host's portion is even larger. So again, the 255 represented by binary, and then .0.0.0, all representing the hosts, and we end up with a range of 192.0.0.1 to 192.255.255.254, which is almost 17 million IPs and hosts. Now, there's a reason I have chosen the 255.255.255.0, 255.255.0.0, and 255.0.0.0 as my common net masks. These are the net masks of Class A, B, and C networks, which is something we'll cover in classful networking, and something you still see with some frequency. The thing to remember is the smaller the network portion, the less room for more networks that you have. So for instance, in this example, the 255.0.0.0, we have very few network space with a lot of hosts space. In contrast to 255.255.255.0, where we have a lot of network space, so lots of networks with only 254 hosts. So the big takeaway is that the network mask breaks your IP address into a host portion and a network portion by masking off the network portion, which means the only part on the LAN that's going to change is the host portion. Every other device on the LAN is going to have the exact same network portion. And the size of the host portion is going to determine how many hosts or how many devices you can have on your LAN. So the network mask defines the network size, the range of the IP addresses that are available within the network. And once again, the larger the network portion, the more networks you can have. The larger the host portion, the more hosts you can have. And we're going to begin calculating these in the next lesson with subnetting calculations. This lesson is now complete. Thanks for watching.